welcome to Civil Engineers Adda. So today's discussion is on cables, analysis of cables. Okay, so let's start. What is a cable? A cable is a flexible structural element which cannot resist bending moment and compressive force. Okay, a cable will never resist any bending moment and compressive force. Only it can resist a tensile force only. So one very important aspect is only it will resist the tensile force. Okay, which means that no compressive force or bending moment will exist on any part of the cable. The cable the cable deflects under the action of loads, so that bending moment is zero throughout the cable. That is what the bending moment is, zero throughout the cable. At any point if you go, the bending moment will be zero. Okay, so you can imagine a cable, it cannot take any compression load. Okay, it will take only the tensile load. So let us start. So let us consider a cable as shown in the figure here. So the cable is holded at the support A. It is fixed at it is holded at support A and support B, and in between, so the support A has two reactions, one vertical VA and horizontal HA, and similarly the support B also has the reactions VB and HB. So one thing you can observe here is the HA, the horizontal force at A and horizontal force at B, they are in the opposite directions, because we have to stretch and hold the cable. The cable should be stretched and holded, which means there is a pure tension will exist. The cable cannot take any compressive load. So fine. So next is, whenever a cable is loaded, here there is a load that is applied is P1, and for an example, load, one more load, unequal load P2, means P1 is not equal to P2. Now you can observe the deflection at location 1, which is Y1, and deflection at location 2, which is Y2, and the distance of this load from the point A, from the support A, is A1, that is given in the figure. The support is A1 and the distance of load P2 from point A is A2. Fine. Now let us see what we can do. So now let us apply the bending moment. Since we are having two equations here, what we are having equations is bending moment at location 1 is equal to 0 and bending moment at location 2 is equal to 0. So these are the two conditions, extra conditions, that will help us to find the tension forces. Okay, now the total length of the cable, or cable you can say the total length of the cable, straight length, that is small l. Okay, the length between the supports is small l. Now let us calculate the bending moment at location 1. Now let us calculate the bending moment at location 1. So always, I already told, the bending moment sign convention is left side clockwise positive and right side anti-clockwise positive. So now at location 1, so let us see, for that multiply VA into A1. So VA into A1 minus, because HA will cause an anti-clockwise moment. It will cause an anti-clockwise moment. You can see it will cause anti-clockwise. So HA into perpendicular distance is Y1. Perpendicular distance is Y1 minus H Y1 is equal to 0. Considering from the left of 1, yes, definitely. Now we are going into the bending moment 2 calculation. Again same convention, left side anti-clockwise positive, right side anti-clockwise positive, sorry, left side clockwise positive. Now the bending moment at location 2 is also equal to 0. So what it indicates or what it gives us is, let us consider from, now again we are considering this from the support B. Now VA again from the main support we are considering. So VA into A2. Since the distance is taken from the left support, VA into A2 clockwise minus H into Y2 anti-clockwise. Okay, there will be one more force additional to this, that is nothing but P1. So the force P1 will be additional, that it will be minus P1 into what distance you will take. The distance here should be taken, this distance is required now. So that distance we can get it from what? We can get it from total A2 minus A1. From total A2 we can minus A1, then we'll get that distance. That is what is written in the equation here. Fine, this is equal to 0. So I'll just erase the unwanted part. Yes, fine. I hope you got it now. Next, from equation 1, so we have to name the equation as 1 and 2. Equation 1 and equation 2. From equation 1 we can say the hy, h into y1 is equal to va into a1. Now you can ask me why you are considered h instead of considering ha and hb. Why you have considered only h? Because when I take summation fx, the summation fx, I already told you that ha is in negative direction, whereas the hb is in positive direction. ha minus ha plus hb is equal to 0. That will cause ha is equal to hb, which means the horizontal forces will be equal in magnitude. Okay, so let us consider as h. So when ha is equal to hb, then we can say, we can take it as a common h, which is equal. So that is what taken there. Yeah, now what will happen from equation 1? Okay, h into y1 is equal to v into a1. So we call this as a beam moment. We call this as a beam moment. Okay, now let us start with the problem. Okay, a light cable is supported at 2 points 20 meters apart. So 20 meters apart. So 20 meters apart. Okay, at the same level. The very important is at the same level. The cable supports 3 concentrated loads. The deflection at 40 kilonewton is 0.8 meters. The deflection at 40 kilonewton is 0.8 meters. So you can see, fine. Determine the tension in the different segments. Determine the tension in different segments and also calculate the total length of the cable. Total length of the cable. Okay. So fine guys. So actually the diagram will not be given. You should analyze the question and then draw the diagram. So here you can see that the cable is supported at 2 points 20 meter apart, and you can see that 3 loads have been given. So exact 20, you have a 20 meter support here and 3 loads have been given. So what you have to do, you have to equally distribute them, that is 20 meters divided by 3 loads means 4 spacings you require. So 4 support spacings, so 4 5s are, so you have to separate each load by 5 meters of support. So 5 meters and at last 5 meters. Fine. So if you want that exact diagram that is drawn here, so just understand the diagram here. 5 meters is given everywhere, and y1, y2, no, we don't know the actual value. Okay, y3 is, there will be three different you can say the deflections. Okay, deflection of the cable according to the load. Okay, fine, that is done. Now let us start the problem. So 5 meter will be this, it is the spacing between the three pointed loads. Now support, the support at A, and there will be a support at B as well. So whenever the support at A here, you have to see that the vertical load is taken as VA and the horizontal load is taken as HA, vertical load VB and horizontal load HB. Okay, so here when I just take a summation, when you take a summation here, one thing you can observe, let us take summation fx. We have to first find out the value of VA, HA, HB and VB to proceed further. So static equilibrium equations. So let us consider static equilibrium equations. Equilibrium equations, which are first one, summation fx equal to 0, summation of fx equal to 0, which means here it is a negative side HA, so it is minus HA, and right side is positive HB, so is equal to HB. Okay, HA plus HB equal to 0. Now which means HA is equal to HB. Let us say that is H. Let's just say. Okay, fine. That is what has been done in the calculations here. Now we find out the reaction RVB. Now we find the reaction VB by taking moment at A. By taking moment at A, here the sign convention is clockwise positive and anti-clockwise is negative. So this is a normal reaction, normal moment. Okay, this is not a bending moment. So now first at A, now first load will be multiplied 40 kilonewton into perpendicular distance, which is 5 meters. Okay, 40 into 5, similarly 30 into 5, 5 plus 5, 10 meters. Next 20 into clockwise, 15 meters. And so at last, next one is VB. Okay, at next we have a VB, but VB is 20 meter far from the support A, so it is in the anti-clockwise direction. So minus 20 into VB, minus 20 into VB, fine, equal to 0. So when you solve, we have only unknown, the only unknown here is VB, so only VB is the unknown. So now what we do, so VB is equal to 40 kilonewton. So VB is equal to 40 kilonewton, fine. Now let us take a summation of Fy. Let us take summation Fy is equal to 0. Summation of Fy, upward forces, is equal to 0. Now according to this, VA minus 43 loads which are pointed to downward, so minus 40, minus 30, minus 20, and again upward is plus VB equal to 0. So 70, 20, 90, so VA plus VB equal to 90. But we have already the VB value, VB is 40, so VA is a 90 minus 40, which is 50. So VA is 50 kilonewton. Okay, fine. Now we have to calculate the bending moment at location 1. So why to we have to apply this condition, because we are not we don't know the value horizontal load h, we don't know the h component here. So for that reason we will apply the bending moment at location 1. So let us see bending moment at location 1. So at location 1, so I'll just erase the unwanted other contents here, sorry, so that we can have some space to work out here. Yeah, fine. So now we can see how one more condition we already know, that is in bending moment at location 1. At location 1 here, the bending moment at location 1 is equal to 0. So here very important thing is, consider you have to take the sign convention, left side clockwise positive, right side anti-clockwise positive. So bending moment at location 1, here the load VA will come first into picture, VA into phi. So VA into phi, and one more thing, that the one more load that comes is HA minus H into perpendicular distance is y1. The perpendicular distance is y1. Perpendicular distance is y1, and the load H here is H. Horizontal force or is H. So minus H into y1 equal to 0. So now we can see, now let us apply these values here. So VA is 50 kilonewton. So the VA here is 50 into 5, and H into y1. So H should be kept as it is. The H should be kept as it is. H into y1. Y1 is what? 0.8 is equal to 0. Therefore the H value. Therefore the H value is equal to, okay. Therefore the H is equal to 312.5 kilonewton. So the H value is given as 312.5 kilonewton. Okay, now what we have to do is we have to get the value y2. So to get the value y2, again we have the condition, that is bending moment at a location 2 is equal to 0. Again same thing here, again left side clockwise positive. So again we have to do the same calculations here, but only thing is make sure whatever is there, the diagram is correctly taken. So bending moment at 2, so I'll just clear off the other things here, fine. So bending moment at location 2 here, if you take the bending moment, so what all loads will come? So VA will come, VA into clockwise, VA into 10 meters, VA into, so the distance here is 10 meters, VA into 10. VA we already got, VA is 50. So VA is 50 into 10, and one more thing will come is H. H will be anti-clockwise. So minus H into Y2, the distance Y2 which is unknown. H into distance Y2 is unknown, and one more load will come is 40. So minus, it will be minus 40 into 5 meters. Minus 40 into 5. So let us see what all things happen here. So H minus H into y2, so minus H into y2 here, minus H into y2, next plus VA into 10, minus 40 into H, minus 40 into 5, minus 40 into 5, everything is done. Okay, now calculate the distance. So the distance is y2. So y2 here is what? The distance y2 is 0.960 meters. So the distance y2 is equal to 0.960 meters. The same procedure is to be repeated for the to get y3. Okay, to get the y3, The same procedure should be repeated. I will not explain that procedure here because the procedure is same. Now only thing is we have to check y3. Accordingly you can multiply the reactions. Now here one thing they have taken here that is very important that I need to explain you guys. Bending moment diagram, while calculating the bending moment from the right side, then it is anti-clockwise positive. So that time it is anti-clockwise positive. So just remember this, and the rest of the thing will be same. So substitute all the values and get the y value. So the y3 value will be 0.64 meters. Okay, so till here all of them have been done. Now let us mark all these in the diagram systematically. Let us mark them here. So VA, HA, VB, HB, phi, everything is done. In place of Y1 here, in place of Y1, Y2 and Y3, we have added their respective distances. Okay, now very important is the angle. Okay, is the angle between the cable and the horizontals. So we have to calculate that. So this is also very important step here. So now we have to see that the theta 1 is calculated. So what is theta 1? So at the location, of the cable where the load is attached, what you need to do is, I will just show one exact location here. So before that I'll just take a pole there. It will be easy for me to explain. Now what we have to do here is that, yeah, now we have load here, that is load. The load applied is how much here? 40 kilonewton. And now we can see that a cable is there. The cable will be done in green color. There is a cable here that is coming in this way, and further it is going with some other angle here. Okay, now this is theta 1, and here its inclination with respect to horizontal is theta 2. Okay, now this is the location at first load. So now we can say that what is tan theta? Okay, here now we have to find the value of length. We have to find the total length. We have to find the total length of the cable as given in the question. So for that I have to find L1. I will divide the entire length of cable into 4 parts. L1, and this is L2, this is L3, and lastly L4. So 4 lengths will be there. Total length of the cable is L1 plus L2 plus L3 plus L4. To find that, we can make use of trigonometry. If you know the angle, you can calculate the tan theta, and that will help us to find the length. Fine. So what is tan theta 1 here? So tan theta 1 is equal to, what is tan theta? Tan theta is opposite upon adjacent. So tan theta is opposite upon adjacent. So the opposite is 0.5, 0.8, and adjacent is 0.5. So tan theta is taken as 0.5, 0.8 by 5. Sorry, no, it's not 0.5, 5 meter length. Okay. So the angle of theta is tan inverse of that. So 9.09 degrees. Now tan theta 2. Okay, while calculating tan theta 2, just it is a calculation thing, nothing much difficult here. So tan theta 2 is, so the triangle will become small here. The triangle will become small here because the triangle will be there only till here now. So concentrate that part now. Now here uh, tan theta 2 is opposite, so that this distance is what? How much is this distance? That distance is calculated as total y2 minus y1. So total of y2 till here, from here till here. So y2, you have y1 is here, so y1 is only this much, so y2 minus y1. Therefore you got here as y2 minus y1 divided by 5 meters. 5 is common because the horizontal component is common, that is 5 meters, as it is equally spaced. Okay, y2 minus y1, y3, y2 minus y3. Similarly, tan to theta 2 is 1.833 degrees. Similarly, now again, if you want to calculate y3, so again you have to take y2, in that you have to deduct y3. Okay, y3 is only this much till here, y3 is only this till here. So if you want this, then it is y2 minus y3. That is what done here. Again theta you calculate, so tan theta 4 will be easy as it is directed, means directly you have the value 0.64. 0.64 directly available, divided by 5 is 7.29 degrees. So theta 3 is 3.662 degrees, theta 4 is 7.29 degrees. Okay, so I hope everything is clear here. It is very clear and it is systematically written also. I hope that is not a problem. Okay, now I will show why we have done this theta, why we have calculated all the thetas will get understood here. Now let us draw the free body diagrams. Let us draw the free body diagrams at location 1, at location 2, location 3. Okay, so there we can apply what is known as Lamy's theorem. So what we are going to find now, to get the tension in the members. So consider the free body diagram at 1. So this is 1, this is at the location 1. Okay, this is at the location 1, the free body diagram is considered. So now everything you have, now you have this value. So I will mention the tension value in the cable as T12, which means the location here is 1 and the next location is 2. So the value is T12. The tension in this cable is given by T12. And now similarly here T23. So similarly, okay, fine. Now first one is T12 is a tension in the member, in this member. Okay, by using Lamy's theorem, so what does Lamy's theorem states? So Lamy's theorem states that, I'll just give you the definition. Whenever there are three forces which are concurrent to each other, then let us say 1, F2 and F3, there are three forces concurrent to each other with an angle alpha, and this angle is beta and this is gamma. Then what is, then F1 divided by opposite, F1 divided by sine alpha is equal to F2 divided by sine beta is equal to F3 divided by sine gamma. So this is given by the Lamy's theorem. Okay, so we know the angles, we will get the angles and we will get the respective forces or tensions we call here usually. Fine, so now we can calculate the in between angle here, 9.09 degrees. How you can calculate the value of the angle is What is theta 1? Theta 1 is 9.09 degrees. So that itself is, you have to write it as 9.019 degrees. And this value here, T12. So T12 should be calculated correctly. So tan theta 2 is 1.833. So this is theta 2, this is theta 1. So now respective force angles you have to consider, which means T1A divided by this angle, T1A by this, okay, which is given here. It is given as 88.19 degrees or 167 degrees. And next force is 40 kilonewton. So 40 divided by entire this value. Okay, so 40 divided by sine 99.09 degrees. And 172 degrees, sine 172. This is 172.743 degrees. So how you will ask me, sir, how we got this? We got this by, so consider here, you're already having 1 point. I'll just rub the unwanted part. Okay, now see, already 1.833 degree is there plus this part. So 90 degree part will come here because this angle we have to multiply. So we have to add. And one more is, only we need this part. Now next is only we need this part. So to get that part, what you have to do, you have to deduct 9.09 degrees. So plus 90 minus of 9.09 degrees. So when you do this, you definitely will get 172.743 degrees. Okay, fine. I hope you got how to calculate the angles. Okay, and one more angle is this angle. Then last one is, yeah, T12. So last angle is T12, you have to calculate. So to calculate this one, you need to calculate this angle. Okay, so this value here, how much you will get that? So at least first part is 90 is there. For that 90 degree you have to add 9.09 degree, then it will become 99.09 degrees. Okay, I hope I have made it very clear how to take the angles, in between angles, that is purely based on the calculation part. Okay, then now how you will do? Now write everything in the order of Lamy's theorem, in the Lamy's theorem pattern. And now next is to calculate. So since you can already calculate the value of 40 divided by sine 172.743, you calculate this part and then just equate this once here, and this also once here. When you equate this, you will get T1A, and when you equate T12 and this one, you will get answer T12. So I have written the answers here. So the two values, so the tension 1A and 12. So the tension in the members have been I'll just indicate here. So we have got the tensions in the member here. So the first member tension value is T1A, and here we have got the tension T what is this, T12 we have got. Similarly, we will get the tensions at the second location and at the third location. Okay, now consider the FBD at 3. Usually if you do at 2 only, it is sufficient. Only if you do at the 2 locations, you will get all the answers here. So I'll just show you. If you do it at 3 itself, it is more than sufficient. Now let us go for the FBD at 3, at location 3. It will be easy here. Now 3 tension Now the tension is T3B, and the one more tension is 3 2. 3 2 means it is starting at 3, starting from 3, and next it will be 2. So at location 3, so the joint here is third location. Okay, so the value you have to find the angle of value here, and there is an angle here, so this value of angle you have to find separately, and the remaining part is this one you have to find. So all the angles have been given here. So T3 by sine 86, I have told you already how to calculate the angles. Similarly, on that basis itself, all the angles have been calculated. So now finally you will get the answer 3 T3B as 315.121, and T32 as 313.33 kilonewton. Okay, now all the member forces are available to us. Okay, now we will calculate. So now we have to calculate the maximum tension. So therefore maximum tension, where it will be, you will get to know by seeing the values. By seeing the values you will understand values. So we have got the tension at A and here. So maximum tension value, so the horizontal reaction H is 312. Where is the horizontal reaction? So the horizontal reaction is 312, and the vertical reaction VA is 50. So horizontal is 312.5 kilonewton, and the vertical reaction VA is 50 kilonewton. There you can find the maximum tension TA. That maximum tension is TA, that is 50 square. Okay, that is 50 square plus 312.5 the whole square, which is 316.47 kilonewton. Means the maximum tension will be at the location A here. The maximum tension will be at location A. Okay, here the maximum tension will occur at this point itself here. Fine. Now we have to check maximum tension that we have got already. Now we have also found out the tensions in the various members of the cable. Okay, now finally we are left with the last part of the question, that is length of the cable. Length of the cable, which is L1. What is that? L1, L2, L3 and L4. So L1, L2, L3 and L4. How you will calculate that? L1 by L1 plus L2 plus L3 plus L4. So to calculate the length, so we have taken this. So I'll just show you the diagram here, very important. So when you want the value, when you want, I'll just rub this unwanted part. Okay, so so this is L1, this is the length L2, L3 and L4. So now what I will do, so if you want to calculate the length L1, so there is already 90 degrees here, all fine, and here there is already 90 degrees here also. So by using the value, how you will get the value L1? So L1 can be got by the cos theta, because it is adjacent. Adjacent is 5 meter by hypotenuse. So what is hypotenuse? L1. So cos theta will give me adjacent upon hypotenuse. So cos theta will give me adjacent upon hypotenuse. So what is adjacent? Adjacent is the values 5 meter and here is the y1, and this is 90 degrees. So the length is L1. Fine. So L1 uh, cos theta is adjacent upon adjacent is 5 divided by the hypotenuse. Okay, fine. So now divided by L1. So L1 is equal to 5 upon cos theta 1. So it is cos theta 1. So similarly, you have to take the length L2, 5 by cos theta 2, 5 by cos theta 3, 5 by cos theta 2, theta 3 and theta 4. So what is theta 1 there? Theta 1 is 9.09 degrees, theta 2 is 1.833, theta 3 is 3.6, everything, all the values you have to take or you have to consider. Okay, fine. So these all values we have got while calculating this one. Theta 1, theta 2, theta 3 and theta 4 are directly available. So now finally you will get the length. When you add, you will get the length of the cable as 20.117 meters. 20.117 meters. So this is the first problem that in which you have understood to calculate the forces, to understand calculate the tension in the different segments of the cable, and how to get the reactions, how to get the values rise, what or how to get the deflections, y1, y2 and y3 dips. Okay, we can say even dip, and calculate the total length of the cable, total actual length of the cable you have understood in this problem. Okay, so the next problem is a cable is supported between two supports at the same level, two supports at the same level which are 20 meters apart, 20 meters apart. 3 point loads of magnitude 40 kilonewton, 30 kilonewton and 20 kilonewton divide the span equally of the cable. If the length of the cable is 23 meter, already the length is given as 23 meter, the length of the cable is 23 meters. Determine the profile of the cable, determine the profile of the cable and maximum tension. Okay, so we have to determine the profile of the cable and maximum tension value. Okay, maximum tension value. So profile of the cable, in the sense we have to find the offsets y1, y2 and y3. Okay, again 20 meter at the same level, and whenever they have given three loads, so 3 point loads, then you have to take four spans, four spans should be taken. Fine. Now let us see 5 meter, everywhere it is divided with 5 meters, and respect to length at the support you have two, one vertical and one horizontal reaction everywhere. Then 40 kilonewton at location 1, 3 and 2. So similarly offset y1, y2 and y3 respectively, and we have a length as L1, then we have L2, length L3 and at last length L4. We have to find those values as well. Okay, yeah, it's not asked for us to get the already the length of the total length of the cable is given, that is 23 meters. Okay, let us see. So to first step is to get the reactions, to get reactions, what all reactions we need to find: VA, VB, HA and HB. Okay, you have to find those reactions. So summation effects here, so H minus HA plus HB will be 0, so HA and HB will be taken as equal to H. Now let us, now taking moment at A, let us take the moment at A. So 40 into 5, the first load will be 40 into 5 clockwise positive, next 30 into 10 meters clockwise positive, and next 20 into 5 meters, so 20 into 15 meters, sorry. So minus there is one which is unknown load, that is VB. Okay, VB into the distance you have to multiply is 20 meters. Okay, minus VB into 20, minus VB into 20 is equal to 0. Therefore what we have to do is, therefore VB is equal to 40 kilonewton. Okay, next one is summation Fy, sum of all the forces in y direction. So there what you have to do is sum of all the forces in y direction. So upward force is what? Va plus Vb minus 40 minus 30 minus 20 is equal to 0. So you can say Va plus Vb is equal to 90 is equal to 90 kilonewton. Okay, so since yeah, definitely we have Va, so minus 40, so there is 20 here plus minus the minus 40 minus 30, and one more load that we have already found out is Vb. So Vb is also there, Vb minus 40, so finally we get 50 kilonewton. So Vb already, that value we have to put, so Va we got that as 50 kilonewton. Okay, now bending moment at location 1. So left side clockwise positive, left side clockwise positive. So you have reaction here at location 1. If you take, we are doing it on the left side, so Va, so Va is 50 into 5 minus anti-clockwise part is minus h into y1, minus h into location y1 equal to 0. So now what is y1? So y1 will be 250 divided by h, y1 will be 250 divided by h. Okay, so similarly you need to calculate the bending moment at location 2. Again we are taking from the left part, left side clockwise positive. So next one is 50 into 10. So here again Va into 10 meters. So Va, so it is 50 into 10 meters minus 40 into 5. Minus 40 into 5 is the point load at location 1, minus h into y2 again, minus h into y2 is equal to 0. So 500 minus 200 is equal to h2. Okay, so 500 minus 200 is equal to h into y2. Therefore only y2 is 300, only y2 is 300 divided by h. Okay, only y2 is 300 divided by capital H. Fine. Now we have to calculate the bending moment at location 3. So the bending moment at location 3 is to be calculated. So that is nothing but at location 3, whenever we say at location 3 here, what we need to do at location 3, we are taking it from the right side. So at location, bending moment at location 3 is taken from the right side anti-clockwise positive. So here Vb 5 into Vb plus you can say y into Hb. Okay, 5 into Vb, so clockwise, so this is causing clockwise moment, so let us take this negative, clockwise is negative, minus this one is equal to 0. So that is what is written here. So at last you will get y3. So y3 is h2, 200 divided by capital H. Y3 is 200 divided by capital H. Now we are doing it by one more method to find the intercepts y1, y2 and y3. So to find the offsets, first what we will do, we will write y1 is to y2 is to y3 is equal to respective deflections. You have to write the respective deflection, like y1 250 by h, y2 300 by h, y3 200 by h. So the respective deflection values you have to write down. 250 by h. Fine. Now what is done? So guys, now what we have to do is you have to divide by 250. So one step is missing here. So 250 divided by you can say as 250 is to 300 divided by 250 is to 200 divided by 250. Okay, so fine. What you can do is, so the ratio will be 1 is to 1.1 is to 1 is to 1.2 is to 0.8. Okay, fine. Now what we have to do, now let us take y2 by y1 as, now we can take y2 by y1 is equal to 1.2 divided by 1. So then you can get the y2 value as 1.2 times of y1. So similarly y3 by y1 is equal to 0.8. y3 by y1 is 0.8 divided by 1. So therefore y3 value is also taken as 0.8 times of y1. Since the total length of the cable is already given to us, which is nothing but the length L1 plus L2 plus L3 and L4. Okay, now total length of the cable already given, that is 23 meters, which is equal to, now I will explain how we got this. By using Pythagoras theorem itself we will get it. So when you observe, so I'll just erase some part here. Okay, now what, observe the first triangle here, first area. So when I draw this, I will get the length L1, y1 and 5 meter, and there is a triangle here. So by using Pythagoras theorem, you can say phi square plus y1 square is equal to L1 square. Okay, or simply only L1 is square root of phi square, which is 25 plus y1 square. Okay, so here it is a square root of y, phi square plus y1 square. So similarly, whenever we take the second triangle, the length here will be how much? The length here will be y2 minus y1. Okay, and at location 3, what will be the distance here? So the distance will be again y2 minus y3. Okay, so respectively the lengths have been taken, and all the lengths using Pythagoras theorem itself, they have been calculated. L2 is phi square plus y2 minus y1, L3 is this one, and L4 is phi square plus y3 square. Okay, so now what you have to do, now very important thing is we have taken, take, I write here, take phi square common, from all terms, in RHS side, in right hand side. So which means we have taken phi square common, and inside the square root has been written as 1 divided by 2. Okay, the power 1 divided by 2. So phi square, if I have taken common, so the remaining inside is 1 plus y1 square divided by phi square, plus y1 square divided by phi square. Okay, next one is what? So y1 square plus y1 square divided by phi square. Similarly, next one, take phi square common, phi square, and remaining is 1 plus y2 minus y1 square divided by phi square, which will give you the same result as that of what is there previously. So similar steps have been done for the other things also here. Okay, phi square common. So at next what we will do, whenever we are having phi square and we have a square root on that, so the square root and the square will get cancelled and it will remain with only phi. So that phi we have taken common, so that phi usually it is taken common everywhere, and that phi is sent to the bottom here because all the phi will come here at the top, at the numerator part, and this numerator part will go into the denominator of the LHS. Okay, fine. Now there is what, now there is a expansion 1 plus y1 by phi the whole square. Here the y1 square by phi square is written commonly as y1 by phi the whole square. Similar thing is been done in the other sides also, similar thing. But here one important thing you have to note down is all the values y2 and y3, all values y2 and y3 have been written as y1 itself, very important part here. You can see here this entire thing here, y2 minus y1 has been written in terms of y1 itself. Okay, you can see that here. So where we have got, so you already know that y2 is 1.2 times of y1 and y3 is 0.80 times of y1. So the two values have been written everywhere. The same thing is being done. Wherever you find y2 and y3, replace that with the respective y1s. Okay, next step here is calculate. Everything is done. Now what you need to do, you need to calculate 1 by phi the whole square value. Now here next step what we have done is calculate the value here. Here what they have done is 1 divided by phi square. 1 divided by phi square value is calculated, which is 0.04. Okay, so that is why you have got the value 0.04 here. And one more thing is divided by 2. How you got is, I have written here, I have put a star mark and written that is a binomial expression. So the above thing, the above entire thing is in this form. It is in the form of, what is it in the form? It is in the form of 1 plus x raised to 1 by 2. Binomial expression 1 plus x raised to 1 by 2. So which is equal to 1 plus x by 2 itself. Okay, 1 plus x by 2 itself. So that is what written here. Okay, that is what has been written here. Now next one, again 1 plus 0.0016 y1 square. So that is written same here, divided by 2. Similarly everywhere you are writing the same thing. Okay, so I hope you got how you got all the values here. You have to multiply in the calculators respectively. So 1.2 y1, I'm just doing this, minus y1 by phi, which means 1 y1, so 0.2 by phi the whole square. When you do this you get 0.0016. Okay, that is what is written here. Okay, now respectively all the values have to be written in this form, binomial expression. So at last add all the values, because everywhere you can find y1 square, y1 square, y1 square, everywhere is there. So add all the values. So you should get the value here as 0.0.0 0.0368 y1 square, 0.0368 y1 square. So at last you will get the value y1. So the value y1 is 4.038 meters. So finally you got the value y1. Now substitute it back and calculate the y2 and calculate the y3, which is 4.85 meter approximately, and 3.23 meters. So finally h value can be calculated from any one of the equation. You can calculate the h value. So where do you have that h value? H value is somewhere here. So y1 is 250 by h. So what is that? Y1 is 250 divided by h. So already you got the y1 value, which is 4.038 meter. So calculate the h value, which is 61.912 kilonewton. 61.912 kilonewton. Therefore therefore the maximum tension value will be at one of the supports, at the supports itself, where you are having the maximum vertical reaction. There will be the maximum tension. Okay, maximum horizontal force and maximum tension, where it will be there you can calculate the tension value. So va square plus h square. So you got that value as 79.580 kilonewton. So the maximum tension in the cable is 79.580 kilonewton. Okay, I hope you got how to solve the problem. So this problem is little bit, you have to work little bit here, but I have made all the things clear. Once if you solve, you will understand. So thank you for watching my video, and please do subscribe my channel, and don't forget to hit the bell icon